Welcome and hello. This is a video exercise in HEC-RAS, and in this exercise, I'm going to simulate Hurricane Katrina flooding. This was an event from August 2005. So what we're going to see on the screen is of a very simplified version of that flooding taking place in the greater New Orleans area. What I have on the screen is my HEC-RAS, and we're going to start this exercise from the very beginning. And let's go ahead and get started here. So I'm going to go File, New Project, navigate to where you want to save this project on your computer. Once you've got to the project directory, click in the title text box and then type in the title of the project, 37, and then click OK. Right, I'm going to use US customary units, so click OK. I have the RAS mapper window open up in the bottom of the screen already. So if you don't already, go ahead and to GIS Tools, RAS mapper. That'll open that up. First thing I want to do is set my coordinate system, my spatial reference system. So project, set projection. And then right here with projection, I need to navigate to my projection file. I do not have a Louisiana or New Orleans projection file saved. So what I'm going to do is head over to this spatialreference.org webpage, which I have up right here. And then I'm going to go click on EPSG for a list of different coordinate systems that I can search through. Here's a bunch right here, but there's so many, I would definitely recommend using this search bar right here. Now, I want to use the UTM north, but I'm not sure which zone. So I have this map that shows the different UTM zones, and Louisiana, it looks like, is in zone 15. So I'm going to go back to spatialreference.org, type in UTM zone 15. Looks like I've already done this. And I want to use NAD 83 for my horizontal data. And it looks like I have a number of options here. So these three options are all NAD 83 using UTM zone 15 north being the northern hemisphere. This first one here, CSRS, that's Canada, and then HARN, this one's a little bit outdated. So I'm going to go with NSRS 2007, and then go ahead and click on that. Scroll down to confirm that it covers Louisiana, and it does. Or New Orleans, okay. It's kind of on the edge of 16, but let's go with 15. We'll click on the .prj file, and then that'll download the projection file to my browser's default download directory. All right, let's go ahead and move that into the project directory. And just to be precise, I'm going to rename it with the word projection. So I'll call it projection EPSG and then 3722. Okay, so with that file saved in my project directory, I can go back to my RAS mapper, navigate to that projection file, click apply, and OK. All right, now it's time to download some elevation data for that New Orleans area. I'm going to head over to the USGS elevation map. In some of my other examples, I've gone right click and then download and use the download terrain data from USGS dialog box within RAS mapper. And this works great. One downfall that I've noticed, and maybe there's a workaround, is I can't see the extents of what I'm downloading. It just gives me the file size and then the description of the file. And for such a large area, I'm going to go with 1/3 arc second, not the 1 meter data. So this website here, I'll go ahead and leave a link to this page in the description of the video. This is where I get a lot of my elevation data for HEC-RAS and HMS as well. I'm zooming in here to the New Orleans area. This is Lake Pontchartrain. Further south is the Gulf of America, and this is the Mississippi River. So I'm going to zoom out a little bit here, and then over in the left panel, click on Elevation Products, and then I'm going to unclick everything except the 1/3 arc second DEM current. And scroll back up. I think I have TIFF. Yeah, GeoTIFF is the default selection for the file format, and then click on Search Products. All right, so it looks like there's 4 different panels here. So if I hover, you can see over in the map the extents of that particular file. So this is the first one. Here's the second one. Here's the third one. I don't know if, yeah, I guess I need all 4 of them. Yeah, I probably need all 4 of them, but it's too bad that one panel couldn't just take care of the entire area. So to download, you're just going to go ahead and click on this link, download link TIFF, and then that'll download to your computer. I've already done that, so I'm not going to do that again. It takes about 5 or 10 minutes, and I'm going to have to wait that long when I import the files anyway. All right, but if you're following along, go ahead and click download link TIFF for all 4. And then once you get those downloaded, we can catch up. All right, I've downloaded those files and I've put them into my USGS directory, inside my terrain directory, inside my project directory. So these are all ready to go. Let's return to RAS Mapper and load them up. So for terrains, I'm going to go right click, create new RAS terrain. And then the next thing I'm going to do is click on this plus icon to load in the files. So this is my project directory, terrain, USGS. Here are my 4 TIFF files. I'm going to click open. And then this does require a vertical units conversion from meters to feet. And then everything else here looks good. So I'll go ahead and click create. The elevation data has loaded in. If I zoom out a little bit, we see the ocean, or I guess this is the Gulf down here. And then this is Lake Pontchartrain up here. And then this dark brown here is the levee. And then inside the levee is the river. Here is the Mississippi River as it's flowing in the downstream direction. Don't ask me why it just stops right here. I believe it continues on this way, but that's all right. Maybe it's just a problem with the elevation data, and it's really not too important because what I'm going to be interested in is the levee breach right here at the I-10 bridge and then over here at the 9th Ward. Okay, we're going to talk about that a little bit later, but what I want to do first is sketch in some of my elements. To do that, I first need to create a geometry file. I'll just do that, call it base. And then let's start with editing and let's sketch in the lake first. So let's see, I'll call that a storage area and then I'll pan up here. This is the industrial canal. So I'll just go ahead and start my edits. I'm not going to sketch the entire lake. I'm just going to kind of do a simplified version of what the lake would be. The model doesn't know anyway. Lake Pontchartrain. Oops. Okay, I think I'm going over the character limit. I'll just call it lake. It's fine. It's the only lake in the model. Next, let me go ahead and sketch in some rivers. And because I want the junction to be in the Mississippi River, I'm going to sketch that in first. And then I'll sketch in another river reach representing the canal, which will intersect that river. I'm going to click on rivers, expand that. Yeah, so that's good. Ready to edit. I'm just going to start right here. And then in the direction of flow, the downstream direction, I'm going to continue doing single left clicks along the center line of the river and then panning when I need to. Okay, this is that awkward end of the river, which doesn't make a whole lot of sense, but I'm going to double click and I'll just call this river and then click OK. Now let me pan up to the top of the canal, which is right here. I'll just do a single left click. I'm going to model this industrial canal as a river. Click here, right click will actually center. Left click, left click, left click. Now I need to zoom in here so I'm close enough so that it recognizes that this is a junction and double click. All right, so for the river name, I'm going to call this canal and then click OK. It's asking me, do I want to split the river into 2 parts, an upstream part and a downstream part? The answer is yes. The downstream part is now going to be called lower. It's the name of the reach 1 lower. Okay. And then the junction is going to be called junction 1. All right, looks good. Next, I'm going to sketch in some bank lines. So I'm going to click on bank lines. And then let me start from the downstream end because bank lines can be sketched in either direction. All right, so I'm just sketching along the bank here. All right, I'm finishing up this bank line with a double click. And then I'll start on the other side. This is the upstreammost part of the Mississippi River, in my model at least. All right, when I get to this corner here, I'm going to turn left and head upstream along the right bank of this industrial canal here. All right, finish that. One final bank line to go. I'm going to go ahead and just cross this and double click. Okay, so we're done with the bank lines. Let's go ahead and sketch in some cross sections. So I'll click on cross sections. We definitely need a cross section down here in the downstreammost part of the river. Okay, so that's done. I'm going to come up to the junction as well and add a cross section at the downstream end, upstream end, and this upstream end right here. Now I also want a cross section right here. That's the upstream end of the river, and one more cross section at the upstream end of this canal. All right, next what I want to do is edit in the 2D flow areas. So we'll click on 2D flow area, expand that, click on perimeter, and I'm going to have 3 major areas I'm going to create a 2D flow area for in this model. And they're going to be New Orleans Central, New Orleans East, and 9th Ward. I'm not sure if that's actually what they're called. That's just what I'm calling it. And then after that, we'll sketch in the actual lateral structures, which we're going to use to simulate the levee breach. So let's start right here on the west edge of this industrial canal. And this is going to be for the New Orleans Central 2D flow area. I'll go ahead and sketch here and then just do some clicks along the perimeter of this area. All right, I'm finishing up the perimeter around New Orleans Central is what I'm calling it. So double click right there. Let's call it NO Central, and then click OK. Now it's asking me what sort of spacing I want between the computation points. Let's go ahead and see what 500 feet looks like. Generate computation points. Okay, that looks good. 397 cells. I'll click close and then zoom out a little bit. So this is what I use for New Orleans Central. Let's go ahead and do New Orleans East now. Okay, so I'll click there to get it started. And finishing this up, double click. New Orleans EAST. Again, let's go with 500 feet in both X and Y direction for the cell spacing. 283 cells. And close. All right, last section here of land is Ninth Ward. So I'll get that started. And double click. All right, and click OK. And then let's go with 500 feet again. Compute, that's 395 individual cells in that area. All right, I'm going to go ahead and toggle off the terrain just so we can see what this looks like. I'm zooming out. Here's the model so far. There's the lake, there's the river, there's the canal. We have our 3 different 2D flow areas. There are cross sections as well. And what I want to do now is add in the lateral structures, which is going to represent the levees, and that's what we're going to use to breach and move the water from the river, unfortunately, into these 2D flow areas. To know where these levees breach is actually a critical part to the simulation and knowing what areas flood to what depth and to what time. So there are a couple Wikipedia articles that I found. Here's the lake up here. Here's the canal. Here's the Mississippi River. Here's Ninth Ward. This is what I'm calling New Orleans Central and New Orleans East. Oh, it even says New Orleans East right here. There is a legend in this map right here. So it shows the different levee breaches with these stars as well as some other areas. Like the pink area is the maximum flood extents. So if you just look at this map, this area was just totally flooded, and a lot of the levee breaches occurred along this industrial canal, including the 2 that I'm going to simulate in this particular exercise. So here's another Wikipedia article. I'll leave a link to both of these articles in the description. Anyway, what was important for me when reading this was the timeline. Here it is. On Monday, August 29, 2005, between 4:30 a.m. and 5 a.m., I'm just going to say 5 a.m. That's when the first levee breach occurred. It was at the I-10 bridge along that industrial canal, and it was along both sides. So if I go back to the map here, I'm going to actually add in web imagery. I'll show you, it'll help us identify where this I-10 is. I'll click on Google Map. I've always kind of liked that one. So let's see, go to map layers. Okay, so the Google map is now loaded. Here is I-10. Oh, there it is, I-10. So right here is where I'm going to add a lateral structure on both sides of the river. And then I also have that in my, so here's my Google Earth. If you get your bearings here, we got the lake up here, the river. Here is the canal. I-10 is right here. So I'm going to put a lateral structure here and here, just sort of at the edge of the bank line. Actually, I should probably add some cross sections in there as well. Anyway, at 6:10 a.m., that's what the Wikipedia article says, there's also a levee breach here at the Ninth Ward. And this breach is only in the eastward direction. So if I bring up the timeline again, 6:10 a.m., levees along the eastern portion of the Mississippi Gulf outlet began to flood the lower Ninth Ward right there. And you can even get a map of that lower Ninth Ward, apparently, which is this area right here. Okay. So that's why I decided to go with these levee breaches. There's a lot of assumptions built into this analysis. Clearly, I'm not doing it justice by only simulating 2 levee breaches and using data like Wikipedia, but I'm just going with it for a first cut. So let's go back to RAS Mapper. And what I want to do is add in a couple cross sections at each of these levee breach locations. So let's go to cross section, and it looks like I'm editing. And now I want to go left to right. Okay, so this is on the upstream side from left to right. And then again, downstream of I-10, left to right. Okay, and then let's go down a little bit further downstream to the Ninth Ward, which is right around here. So I'll just add in 2 more cross sections, and that looks good. Okay, let's add in the lateral structures now. Here is the lateral structure, and I'm editing. So I'll just put it near the bank line for the most part and sketch it from upstream to downstream. So single left click to start, and then another left click. For a name, I'm going to call this Ninth Ward Levee, and then we don't need it to be 100 feet. How about just 50 feet? Okay, so there's that levee. We're going to go ahead and actually make some additional edits over in the geometric data editor a little bit later. Let me go ahead and add the lateral structures right along 10th Street now, or I-10. So this is into New Orleans East. I'll do a single left click and then a double click to stop. I'm going to call this New Orleans East Levee. It's probably called something else, but that's what I'm going to call it. And then on the west side of the Industrial Canal, single click, double click, New Orleans Central Levee. That will, it'll make it easier for me to match up that area with that levee, and then go ahead and click OK. All right, so I'm going to stop the edits, click OK. Okay, it's just a warning. Let me see. Okay, looks like we're good there. Let's go ahead and check out that geometric data editor. So edit geometric data. I'm going to click on File, Open Geometry Data, click on my geometry file, click OK. All right, here is the geometry. The first thing I want to do is change the color on this 2D flow area. That always drives me nuts. I'm going to go up to Edit, Lines and Symbols, and then for Scheme 2D, let's just make it white. That's a little bit less intrusive. All right, and I'm going to make the river a little bit darker blue or thicker blue. So Lines and Symbols again. Here is the river. Let's go ahead and make it thicker. All right, so we can see the river easier. All right, let's go ahead and modify. Let's see, how about Manning's end value? There's just so many things to do here. So we're working on the canal first. We have a number of different cross sections here. I'm going to be very simplistic and just say the Manning's end is 0.05 for every single cross section because we're not really focused on flow through the river. We're focused on the levee breaches and the resulting floodwaters. That's what we're most interested in here. So I'm going to go to end value and just delete that 0.05 and then advance to the next cross section. Click on end value, click delete 0.05, and then repeat that for all the cross sections in the model. Okay, so that is good for the canal, but I do have some cross sections in the river, and I have two river reaches. Here's the first reach, so I need to, again, delete 0.05, and I think I have one more. Okay, that's good for the upper reach of the river. The lower reach of the river has just two. Yeah, just two. Okay, that looks good right there. So I think that's all I need to do for the cross sections. I'll close that. Go ahead and save the geometry. Next, I need to define the breach data and the lateral structure. I'm zooming in here at the lateral structure. This is at the I-10 bridge. I'm going to click on lateral structure. So this is east and this is central. Let's do a central first. Edit. This says left overbank. I want to change this to right overbank. Okay, breach, we'll do that in just a bit after I define the weir and embankment. I'm just looking through all the things here. Tailwater connection. This needs to connect not to the east area. It needs to connect to New Orleans Central, which is right here. Okay. Looks like the map updated. That's good. What else? What else? Okay, I think I'm ready to input data for the weir and embankment. Now, right now, the elevation shows, where's the elevation? Right here. It goes up to maybe like 10 feet. Let's go ahead and make it 15 feet for all three lateral structures. So I'm going to delete the existing data, type in 0 here. The length of the weir is 223.3, 323.3. And then for an elevation, I said 15 feet. And then I'll go ahead and click OK. Okay, so there's the weir. The breach, here is our chance to input the breach data. I'll say the center is, well, first of all, the checkbox right here, breach the structure. That's important. User entered data. We'll go with that. The center station, I'll say is 150. The bottom width, I'll say is, I don't know, 30. And then the final bottom elevation, how about 6 feet? And then we'll say a 4-to-1 side slope. The breach formation, let's say it occurs over the 30 minutes, so 0.5 hours. And then it's going to be triggered at 5 a.m. So this is where I type in 29 August 5th, 2005 at 5 o'clock a.m. And then for the breach progression, I'll go ahead and just use the sine wave. Okay, so I think everything's good there. Okay. I'm not ready to enter the unsteady flow analysis data, so I'll just close that and then return to it later. All right, so one lateral structure and breach data has been created and assigned and ready to go. Now I need to do the same thing for two other lateral structures. All right, I finished making all the edits to the levees. This is the levee at the 9th Ward levee breach. So if I click on edit and then I click on breach, you can see this data. The only thing that's really different is that it begins the breach at 6:10 a.m. on the same day, but the general shape is the same. It takes half an hour to total the breach. And the downstream connection is, let's see, it's right here into the 2D flow area called 9th Ward. All right, so the levees are all built. The levee structure and the breach data is all ready to go. Next, it's time to create a boundary conditions for the model. To do that, I'm going to go up to Edit, Unsteady Flow Data. Now, I've already added a stage hydrograph here off camera, and that's what I'm going to do for all three. What we have is the upstream cross-section of the river, the downstreammost cross-section of the river, and then this is the upstream cross-section of that industrial canal. So if I click on the stage data here, what I'm going to do is set the elevation to 8 feet at the beginning of the simulation. It's going to be a 48-hour simulation, so 2 days. After 1 day, the stage is going to increase to 14 feet and then stay at 14 feet for that entire second day. Now, one of the problems with this model is I don't know what this data is, and I didn't even, try to figure it out. But one of the easy things to improve the model would be one, to get the correct levee location and breach data, and then two, get the correct water surface elevations, because that greatly influences the hydraulics of the model. All right, so here is the cross section at the downstream end of the river. Again, I'll click on stage hydrograph. I'm going to type in an 8 here, and then let's say it goes up to 14 feet here, and then down at after 2 days is 14 again. Click interpolate, and then that's good. One more time here. This is at the upstream end of the industrial canal. So stage hydrograph, there's 8 feet, there's 14 feet, then 14 feet again, interpolate, and okay. All right. Also, we need initial conditions. So for the lake, the lake really isn't that important. I drew it in, but it's not really necessary for this model. It's not connected, and I probably should connect it. I'll just say it starts at 8. And we don't need a warm-up period because we don't have water flowing through the 2D area, at least not before the levee breaks, which will be 5 hours and also 6 hours after the start of the simulation. All right, as far as initial elevations for the 2D flow areas, I don't want any water in there. I want them to start dry, so I'll leave those fields blank. This is optional right here, and I think we're ready to save this data. I'm going to go up to File, Save Unsteady Flow Data. I'm going to call this Stage 8-14-14, okay? And then click OK. All right. Next, I want to run the model. Let's see if this works. I'm sure I forgot something, but we'll find out. Run, let's see, unsteady flow analysis. Now I'm going to name the plan what I named the hydraulic data. Save plan. It's going to be called stage 8-14-14. Okay. Same with the short ID. We're going to run the geometry preprocessor, unsteady flow simulation, post processor. We're going to start this on the day of the levee breach, but at the very beginning of the day, 29 August, that's 2005, 100 hours. And then it's going to go 2 days. So it will go until the very beginning of the 31st, 2005, also 100 hours. All right. 1 minute time interval is probably all right. For the mapping output, I want to change this to a smaller time interval, maybe like 6 minutes. And then everything else here looks all right to me. All right, let's go ahead and click compute and see what happens. Looks like it's running. Okay, looks like that was successful. I saw something up here. It says extrapolated above the cross-section table. So it's in the canal. I think I need to increase the hydraulic table data at higher elevation than current. So let me go ahead and do that real quick. We'll come back and run it. I think this is a quick and easy fix. And then after that, we'll take a look at results. I want to go to the geometric data editor, but then click on H tab params. And then for the canal, that's good. So what's the problem here? Okay, yeah, that's the problem. If you look over here on the diagram, the hydraulic property table only goes up so far. So I need those lines to go further up because the max elevation, the max stage is 14 feet. So what I'm going to do is just change, let's see, is that the case for all of these? Yeah, pretty much. I'm just going to go ahead and increase the number of points from 20, which is the minimum, to maybe 50. Let's see what that looks like. So 50, 50, 50, 50, 50, and 50. We want to make sure that those lines go above the max water surface elevation. That's good. That's good. Okay, that needs a few more. So let's go with maybe 70. Tab off and over. Okay, that's good, good. Good. That's like too many right here. I could probably change this to like 30. Okay. All right. I'll go ahead and click OK. File, save geometry data, and then let's go ahead and click compute again. All right, fantastic. So it looks like we have a successful run without any errors or warnings. Let's check out some of those results. Let's go to RAS Mapper and then zoom out here. All right, I'm going to toggle on the terrain first, and then we can look at the street view later. So there is the terrain. Let's go ahead and scroll down to results, expand that, click on our stage. So here's the stage, toggle that on, click on water depth. Okay. Yep, that's kind of sad to see, but at least the bottle appears to be working. For the first time step right here. Okay, hold on a second. Yeah, so I'm noticing some out of bank flow right here. That's just because I needed to put some more cross sections in the river. But of course, this part of the model is really not too important. Just don't think that this is wrong. It just looks wrong because I was lazy and should have put more cross sections. All right. So that's 1 o'clock, 2 o'clock, 3 o'clock. The levee breach is right there. Yep. Oh, that was actually really accurate as far as the timing goes. So that's 4 p.m., 6 p.m., 8 p.m. on the first day. We're starting the second day. And as I zoom out, you can see the full extent of the flooding. Now, keep in mind, it's not going to flood past the 2D flow area as I've sketched it out. Let me go to the very end of the simulation and turn off the terrain. So you can see, yeah, that's actually similar to what we saw on that map as far as the total expanse of the flooding, which was this right here. So that, to a certain extent, matches this. Let me go ahead and zoom in and let's toggle on the Google Maps now. And I've reset the simulation to the first hour. What I want to do is just advance it to, let's see, where's 5 o'clock, right? This is 4:42. You can see the time right here. I'm going to turn off the 2D flow area. Okay, yeah, we don't need to see that there. So if I just advance, this is 4:48. This is right here is 5 a.m. This is exactly when the levee is going to begin to breach. So we should see some breach out here. Zoom in a little bit more. It's 5:18, 5:24, 5:30. At 6 o'clock. Now 6:06, so we should see the ninth ward. Yeah, here's the ninth ward levee breach right here. We should see that begin to breach at 6:10, 6:30. Yeah, there it goes. 6:45, 7 o'clock. I can toggle on the flow arrows. So if I zoom in, you can see that the velocity of flow is fairly high around this levee breach. And then let me turn the arrows off and then turn the particle tracing on. Okay, it's kind of hard to see the particle tracing. I'm going to go ahead and change the color. Let's go ahead and make it black. So 0, 0, and 0. Okay, yeah, you can see there's a lot of flow and high velocity flow leaving the structure here. This is at 11:18 a.m. on the first day. Okay, the ninth ward levee actually has better particle tracing results. So you can see that the flow is leaving at a high velocity right here. And then inside the river and then out in the 2D flow area, it's moving a little bit slower. Right here, we have the fastest lines. Let me toggle that off and just turn on the flow arrows. Yeah, so that's sort of what I was expecting, the flow coming out of this breach right here. All right, the last results I'm going to look at while we're dealing with this is the 1D flow through these lateral structures due to the levee breach. I'm going to go up to View and then Profile Summary Table. And then what I'm going to select here is my reaches, and I want the canal, so that's good. And now for the table, I want to select lateral structure. And then also I want to select all the profiles. So select all and then except for the max and then click OK. So these first bunch of rows here, this refers to the New Orleans Central Levee. And as you see, we have no flow for the first 5 hours. And then at 5 a.m., that's when the levee breaches. And then we have a bunch of flow. If I scroll down to this is the New Orleans East Levee. Again, no flow until we have the levee breach 5 hours in. And then finally, the Ninth Ward Levee. No flow until 6 a.m. because remember, it reaches about an hour later. And then here is the flow rates through that levee. All right, well, that was it for this exercise. What we did was simulate the levee breach in the greater New Orleans area based on the events of the Katrina flooding that occurred in August of 2005.